Hello everyone, this is a case study of parametric design. Let's take a look a little bit first of all at the case study. The case study is asking us to create everything in a parametric fashion. So, what we have as a given, first of all, obviously we have to create everything as ISO constraint. We have to set a certain parameter equal to 100 millimeters, and then derive from this parameter we're going to have a multi-section solid with two sections. The first section is a square whose dimensions, both of them are A. The second dimension is a rectangle that have a dimension of A from one side and half A from the other side. Both sections are centered at 0, 0. Now the distance between them is equal to 2 times A. And we are requested to use the zx as the plane for the first section. So section 1 will be on zx and the second section. Of course, this is a case study, so we have to apply everything that we are learning throughout the different tutorials. This is the expected result. So it creates this multi-section solid. Now, in a second stage, we're going to create a plane that has a reference A from zx. Then we're going to create a center square where the side is 1.5 times A. And then we're going to create a path of thickness 1/4 A, but extended from both sides. So it's going to be half an A overall. Then finally, we are going to intersect both bodies, and we're going to try some different elements. And the question is, what is the mass of the intersection if it was made out of titanium? So the way we are going to do that is actually we're going to have fun a little bit with this. We're going to create a table with dimension and materials, and we're going to see the mass of the intersection. So we're going to have A, we're going to have material, and then in here we're going to have the mass. We're going to try A for different values. For 50 millimeters, for 3 feet, so we can put 3 feet, for 500, let's try different dimensions, for 1 meter, and for, I think that covers every much. Let's do another 1 meter with a different material. We're going to try titanium, we're going to try aluminum, and we're going to try titanium and aluminum again for both of them, just for the fun, and we're going to create the mass. So let's go ahead and get started. I'm going to move this on the side, and we are going to start with our case study. So mechanical design, part design, PRT, RH, case study of parametric design, V01. It is very important to actually do things the right way. So we're going to click insert and create a geometrical set, and we're going to call it reference element, so references. What I'm going to do, since we were asked to create it based on zx, I'm going to hide the other planes, and I'm going to start with the creation of, well, I don't know where my reference elements is. You can right click and actually try to select it here, so you can create like reference elements and get them. Or the other way that you can do, this is what I like to do every time I restart on CATIA, is to reset all options. So you right click, customize, go to toolbars, restore all contents, restore positions. Like this, everything goes back to where they're supposed to do, and you can expect to find your reference elements in here. So let's go ahead and create the reference elements. So if you remember, what we have is 2A from one section to the other, but then also in this exercise is going to be at 1A. So first of all, I am going to, let's go ahead and go to the functions in here, create a new parameter of type length. So new parameter, we're going to call it A, and let's give it, what was the first dimension we talked about? 100 millimeters. That was in the exercise. So let's just give it 100 millimeters. apply, and click OK. So you should see it pop up in parameters in here. If you don't see it, go to, let's try to remember, Tools, Options. Oh, actually, this would be something really cool to show you. I'll come back to it in a second. But let's first of all make sure I can show the parameters. I forgot a little bit where it appears from. Yes, here. So you go to Tools, Options, click on Infrastructure, Part Infrastructure, then click on Display and make sure that Constraints, Parameters, and Relations are clicked. If they are not clicked, they would disappear from here. So Tools, Options, Infrastructure, Part Infrastructure, Display, and make sure that you select them so that they pop up. So the other thing I was just saying that it would be interesting for you to see, I'm going to move these a little bit like this, is, so this is sometimes when you don't have, actually I don't know where I went, Tools, Options. This is something that sometimes when you don't have access to a mouse, you can click General, Device and Virtual, click Tablet Support, and activate Transformation Path. This creates zoom and pan, and I will just and rotate features in here that I will demonstrate in a second. So let's go ahead and start creating those plane for references. The first thing we're going to do is we're going to create the first plane with an offset of 0. This is the plane that we're creating it. We're going to call this, let's go ahead and press Alt Enter, go inside the feature properties and call it first plane. And then we're going to create another plane, and it's an offset from this one. We obviously know it's going to have a distance of a later, so we're just going to put it like this for now, and this one's going to be 2a. Let's just put them like this. This one is going to be the mid plane, and this one is going to be the last plane. So the next thing that I want to do is this one is an offset of 0, but this one is an offset of a from the other one. So I'm going to click Edit Equation, and I'm going to make it an a from this one. And this one is in reference to this one. This is another a. So that makes a total of 2 a's for both of them. I'm going to click on the yellow one to center them, and now I have my 3 reference planes. So if I go back in here, this is what I'm trying to create: a cross section in here, another one in here, and another one in here. These 2 cross sections, we're going to use them to create a multi-section solid. This cross section we're going to create to another one, and then we're going to do a Boolean operation. So it's very important that we also create another part body, and that we pay very, very close attention to, did we do define and work object? Yes, insert body. So we have another part body, and this one is going to be the mid body. So also, as we are creating these different elements, it's important to make sure that we are doing them inside the part body so that we can create the intersection. So I'm going to right click now, define and work object. We're going to start with our 2 sketches, and I'm going to hide the z-axis plane because we're going to use the first plane. So sketch on the first plane, center it, and it's going to be a centered rectangle. So centered rectangle, and the dimension are going to be, let me see back in here because I forgot, it's a square of dimension a. That makes it easier. So this element, we're going to set it equal to this one, and this element, we are going to make it set to the value a. That's for the first one. Now we close it. Now we're going to create another sketch while we are still in the same part body. Sketch 2, oops, we should have no plane selected. Or we can select this one and sketch 2. Let's zoom in. The dimension for this one is also rectangular, it's also centered, so we can't click on the center, but it's going to have, I should have double clicked the dimensions, but it's going to have, let's go ahead, start with this one and make it equal to this one divided by 2. And then this one, we make it equal to A again. All right, so now we have it all for these different elements. We can go ahead and define the mid body in here. Make sure that you define which part body. And we're going to create a sketch on this one. And this one is going to be equal to, so this is the one, and it's going to be 1.5a. So let's select the center, go back here, double click, and then close this. Make sure that this one is equal to this. So actually there's another way to do it. Sometimes it's easier to actually just click on the function, and then you would select this and you say add formula equal to this. Okay, then it opens it back again. You click this one, add formula is equal to this. There's tons of ways to do it. Now, we know that this should be 1.5. So actually this one we should do times 1.5 for it to be correct. Apply, okay, and we are all set with our sketches. All right, so now we go back to this one, define working object. We're going to create the multi-section solid. So the multi-section solid, this is the icon for it. So we're going to select this sketch and this sketch for the multi-section solid. Click on preview, and this created this first body that we are talking about in here. This is very good. And we click OK. I'm going to show you some things in the end if you want. I mean, you can change the cross section, you can change how it fluctuates. So you can create actually wherever you want. The second thing, we're going to define in working object in here. And we're going to click to create a pad on this one with a mirror extent. And there was a dimension relevant to A, which was 0.25a. So edit formula in here. And we're going to put A divided by 4. And preview, this creates the second part. Let's go ahead and just color things around. Part body, this one, let's just make it something bluish. I like this blue more with some transparency. And also this one, let's make it something greenish with some transparency. And this shows us a little bit what's going to happen. We're going to have like a slanted intersection between both of them. But what's more important, let me go ahead and do it before I do the intersection. If you come and change A to 25, everything updates itself because everything is driven by one dimension. If you update it to 5 feet, it automatically updates itself. Actually, I should be doing, this is a pan in here, this is a rotate, and this is a zoom in, zoom out. I'm much more used to these different views, but all to the mouse, but this is very, very useful. So the last thing, we have now the two bodies that are both of them created. We don't have we don't need the reference elements. What we're going to do is insert Boolean operations and intersection. We're going to intersect the part body. Oh yeah, we have to start with the other body. We're going to intersect the mid body to the part body. Click preview, and okay, and this is what we have. This is the part that we have with all the reference planes. We can hide the reference planes, and actually now we have reframe on. Now we have the part body that we wanted. So this is a little bit the demonstration. Let's go ahead and apply the material and apply the different dimensions and fill the table together and see how this would go. All right, so let's see. We have, so this is what we need to have with the intersection. Let's apply a 50 millimeters. So double A here, 50 millimeters. Where did it go? Let's zoom in like this. Ta-da, it's so small, I know. 50 millimeters versus feet. And let's apply a material. I'm gonna move this a little bit to the side. We're gonna apply the material. What did we say? Titanium. So you can pick stuff from here. You can create your own material. Titanium, make sure you apply it on the overall body. And the next thing, we're gonna click on this one to measure stuff, and we're gonna measure it on the overall thing. And this will show us that the mass, so the volume should, well, yeah, of course the volume should change and the area and so on. The mass is 0.209 kilograms. So we have another titanium, but it's in 1 meter. Let's go ahead and double click on this and make this 1 meter, and of course fit all in so that we can see it. And what else? That's it basically. Inertia, we apply it here. Well, 1 meter of titanium, that's gonna be heavy. This is 1672.5 kilograms. Okay, that's a lot. But well, then again, we did use 1 meter and the intersection, so that is big. Another 1 meter we have is aluminum. Let's go ahead and remove the titanium that we have. I don't know if we can remove the material from here. We can't really do that. Yeah, but we can apply this one here. What did we say? Aluminum. All right, let's see if it worked, because if it's worked, it should not give us the same value, hopefully. Measure inertia. Let's see. Well, hey, we do know that aluminum is lighter than titanium. 1016.25. I'm taking the value from here. And we can see the density of aluminum. And finally, we have 3 feet. So 3 feet is very close to 1 meter. I mean, 3 feet is what, like 90% of 1 meter or so on. So let's go ahead and change this to 3 feet. Actually, you saw what happened. It moved it to millimeters, so it's like 914. So it's gonna be very, very close. We're like gonna lose, I don't know, 776. I mean, so like 776.979. So if I copied everything right, these are the different. Sorry, but my OCD requires that they all look the same. All right, so this concludes a little bit this tutorial that shows you a little bit how we do a multi-section solid, how we do an intersection, how we create parametric. So this explains to you a little bit some processes that can be very, very, very useful in your own design. All right, so best of luck practicing, and thank you so much for listening to it.